All right, we're live. Hello, everyone. To those watching online on the live stream, and to those on the VOD later. Hi there. We're really excited. We're really excited to hold another live community call and tell you all about the latest updates from the product since last month. But before we continue, in case you're new to these calls or to OpenReplay, let me quickly tell you what we're doing here, what we're talking about. OpenReplay is an open source session replay suite for developers. That means we help you see exactly what your users see when they get stuck, as if you were sitting next to them. If you want to know more, stick around or visit openreplay.com. Now, on today's agenda, let me quickly here. All right, so we'll have first Mehdi, our CEO, discussing quickly the updates since last month about the product. Then we'll have Alex Kaminsky, core developer from the team, discussing a little bit about the internal architecture of our tracker code. And finally, our guest speaker, Lucas Costa, who will quickly talk about how to get started with JavaScript testing. All right. So without further ado, please, Mehdi, take it away.
Sure. All right. Hi, everyone. Very excited to be here as usual. Well, let me start with the product updates from last month. So we released version 1.6.0, and I guess without any doubt, the biggest update here was the introduction of the dashboards, right? So the ability to create custom metrics and then build them in some sort of dashboards that you can then share with the team. So if you think about it, we've been going from an architecture of the dashboards that were like almost predefined, just a set of widgets that you can simply add or remove, primarily targeting performance metrics. And we thought it would be better, obviously, to leverage all the data that we have, the different user behavioral kind of events like clicks and visited pages and inputs, and then all sorts of technical metrics, whether they're related to performance or to the dev tools that we're capturing, things such as like the Redux, actions, or the HTTP request, and being able to create custom metrics. So this way you can basically focus on what matters the most for your product, and then using those custom metrics as Lego blocks to build dashboards and then share them with the team. So this is basically, I would say, the biggest add-on that we released in V1.6. On the session replay level, what we've done is, if you can go back, yeah, thanks, Fernando. So on the session replay level, what we've done is basically improving the time to replay. So by the time you click on that play button, it took some time before downloading that file. So basically, a session replay in OpenReplay is all those DOM mutation and technical events that we're capturing, and most of them are stored in the form of files on our object storage service. And then by hitting that play button, what the front end will be doing is it will be downloading that file and then building up that UI, what we call the recording page, by also displaying on the right, the list of user events and populating some other areas on the front end. So we have optimized those queries, and then it's up to 3 times faster. So to replay a session, what we call the time to replay. And then we have I would say worked on few frictions that the community, that you all have been reporting to us lately, which is, hey, I'm using the recording page, but then it's pretty hard to fast forward. I cannot, drag and drop the slider. I cannot basically slide through the timeline. So this is something that we added recently. And then we're also displaying now in the replay all of the clicks. We're animating those clicks, so we make it much easier for you to see where your users have been clicking. Now, remember, for the session replay part, we show all of the clicks wherever they happened on the screen. However, on that list that we have on the right, we only care what we consider to be a click event. We only care about certain events. So we only care about clicks that happened inside a button, on a link, on a select, And that's basically what or on an input, that's basically what we're going to be displaying on that list of what we call user events, the list that you see on the right side of the screen. On the tracker level, we have moved from a basic XHR implementation to the Fetch API, and that allowed us to basically get rid of some really annoying bugs that we had on some sessions. So basically what happened is sometimes the end of the session, the last few seconds couldn't be captured. And the reason behind it is whenever you get out of the page, whenever your users get out of the page or close the browser or the tab, well, we get the batch, all of those, last messages and send them to the backend. But then what happens is as soon as the tab is dead or the browser, so basically what happens, those XHR gets canceled. And that basically resulted in some missing parts at the end of some recording. So by moving to the Fetch API, we could leverage that keep alive attribute. And in this way, we are sure that basically the request would outlive the tab. On the plugins level, we improved the request sanitizer for the Fetch and Actus plugins. So now you can redact sensitive information, whether they're in the body or some of the headers. It's up to you really to do whatever you want with it. You can even redact the entire body, whether on the request or on the responses. So that got much easier in those plugins. Deployment-wise, and as we were explaining over the last community call, we moved to the native Cube ingress controller, which will allow us to benefit from the load balancer or the load balancing algorithms. I'm especially thinking about the sticky sessions, upstream probes, traffic distribution. So we got rid of the Nginx implementation and moved to the Cube's ingress controller. And then we also added Cert Manager. So now whenever you install the community edition, you don't have to care about renewing the certificate by running that certbot script every now and then. So it's all taken care of by the Cert Manager now. So the deployment got easier and better in that regard. On the development level, we added the support of HashiCorp's Vagrant. And so basically now, if you're looking into contributing to OpenReplay, we made it much easier for you to run the entire backend and everything else on Vagrant. And for those who are on M1 or ARM machines in general, you could use Kalima as well, which is something that we do support. All right, what's next? What's happening and what's coming out in v1.7.0? So basically what we are trying to do over the next few weeks, maybe even more, we're trying to answer two questions. How can we get rid of all of the frictions that we're getting? And I'm not just simply thinking about the UI. Friction in deploying OpenReplay, frictions when it comes to the documentation, the different how-tos, frictions when it comes to using the UI. So how can we greatly improve that part? So we're really working on that. You're going to see a bunch of how-tos, whether in the form of videos, in the form of articles in our documentation. You're going to see plenty of examples. Some of you have been asking for examples with Nux or Next, which our documentation is lacking today. But that's not only there. We're also redesigning the UI, and we started with a dashboard page. And now next we're going to the session replay. So there's going to be a full UI redesign to get rid of all of those small frictions. I'm thinking about that URL that you cannot easily copy if you want to. You're seeing one of the users on a specific page and you want to copy the URL, we have to right click, but it's not, that obvious on the UI and the recording page right now. I'm thinking about that timeline, especially if you get a lot of issues, then it get really cluttered and you cannot go and, check only those, issues that you care about. So there are plenty of improvements that are going to be released over the next few weeks. But we're also now, I think, we'll be handling large recordings in a better way. So if you think about it, for small recordings, and again, since we're downloading files, the bigger the recording, the more events we may get, and then the bigger the file. And so now we're trying to slice that into different chunks or into different files to make it much easier for you to, and much faster to replay. Remember that time to replay is also an important metric that we're looking at. On the analytics level, we're taking out funnels and errors, which are today, if you look at our front end, which are like 2 complete sections, and we're adding them as new types to the dashboard. So this way you can create your dashboard, and that's going to be a mix of predefined metrics with custom metrics that you have just created, with funnels, error and session replay. And the idea behind it is to be able really to build your dashboard from A to Z, and being able to use any of the components we have on the front end. And then there is the second question that we're trying to answer to, which is we're seeing some bottlenecks, and we're chasing every and each one of them in our backend. And so there is an ongoing work on the backend. So we are refactoring all of our Go microservices, rethinking some topics, the way we build and distribute messages, the way we consume them. So that work is also going to continue over the next, I would say, the next few weeks. And part of that, what we have done also is that we've taken out the heuristics component. And so the heuristic is basically the ability to analyze a session, right? So whenever we capture a session, what you see on the left side of the session list on the front end is sessions that have got errors, or sessions that have crashed, or sessions they're like facing some memory leaks or high consumption of CPU. Well, this is what we call internally heuristics, and now it's a separate service. And the idea behind it is we want to allow the community to build on top of it, right? We want to allow the community to add more heuristics, to be able to easily customize it, and then at the end of the day, better fit their needs. So these are the things that are going to be coming out next. Okay. A big thank you for our contributors over the last month. Thinking about Bart Reap, he helped us, craft and I would say update the documentation when it comes to deleting recordings and cleaning Postgres. Germain Carré for his how-to for deploying OpenReplay to OVH Cloud and Ubuntu machines. Avrami Friedman for the implementation of the HTTP interceptor for Angular application, which we haven't yet released, but that's going to come next. Amit Abitbul for the ability to cache private resources like CSS or fonts using custom headers. And then Eric at Diff Agency for overriding the local and session storage in Tracker. A big thank you again for all those contributors. All right, without further ado, I'll be passing on the mic to Sasha, who's going to be presenting the Tracker and the architecture behind it. So Sasha, if you can take it from me.
Yeah, okay. Thank you, Mehdi. Hi all. My name is Alexander. I am currently a core developer here in OpenReplay. And today I will briefly overview the Tracker, which is the place where the pipeline of the OpenReplay essentially starts. So the Tracker is essentially the piece of JavaScript code written in TypeScript, of course, that allows recording user activity on a website by injecting it into the website. Yeah, next slide, please. So the Tracker does its job mainly by recording DOM mutations and user activity, which can be lately visually recreated on the other end. This approach is basically much more efficient than, for example, video capturing that is essentially impossible to do in any efficient way on websites. The next slide, please. So besides the essential information that is required to recreate the visual part, Tracker also captures a lot of plenty of hidden but important technical data. such as performance metrics, logs, of course, JavaScript exceptions, data flow that happens in the requests or inside the storage, like Redux and MobX, etc. And even custom events that can be defined by user, by client. So yeah, all this stuff is shown in DevTools section in the player. Yeah, a lot of things are captured. Next slide, please. So yeah, speaking architecturally, briefly, Tracker consists of several parts. The main part, which is can I point here? No, I guess no. So here on the picture, the square that is called the rectangle that is called tracker is a main part which coordinates all the other parts and contains also the API methods that could be called by a user, as well as some utilities. But the main goal of it is coordination of other parts. Then of course the DOM observer, which captures all the DOM mutations that have been talked about before. As well, there is a list. There is a set of modules which are done actually in the same interface way, which gives the possibility actually to extend Tracker with plugins. The plugins that we also deliver, but potentially there can be user-defined plugins. So it's extendable. Yeah, there is also a web worker part in the center, you see, where some part of the job is done. The job that can be done in web worker, it's better to place in web worker because, as you know, JavaScript is single thread language, so it's better to put away all the things that could block the main thread. So yes, on tracker start, it sends the start request to the backend in order to validate or receive the new session token, which is stored inside the session storage. So this session token is actually a JWT token, which also contains the session unique identifier, which also contains a unique session identifier inside of it. And after the start, all the modules that were initially subscribed on start event, they wake up and start to send the messages. All the modules, including the main one, which is DOM observer. Afterwards, those messages are sent to web worker, where they get encoded into our binary message protocol, using our binary message protocol. which is basically very compact representation of the data that we're sending, which is much better than JSON, for example. Things I don't know actually about precise percentage, but yeah, we should check the numbers. Yeah, so it's better than JSON. Yeah, and afterwards it gets sent to the backend in the another request inside the another request. So yeah, generally that's it. That's happening till the tracker gets stopped or the user leaves the page, and on the next page this happens again, but with the session token actually taken from the session storage, and in case it's already there, it is just gets validated with the start, and all the process starts again. Well, yeah, I think that's it for today from me. And yeah.
All right.
Now,
Perfect. Thank you, Alex.
yeah.
Excellent.
Thank you.
Awesome. Very interesting and very complex subject. So remember that we're going to be doing this type of overview of our internal architecture on every call. So you can learn a little bit more about how we do things on every month. So now let's go to, oops, not that, sorry, to add Lucas and have him share. Hey, Lucas, his
Hey,
screen.
hello. Yeah, let me share another 1 second.
Yeah.
Let's do this. Share screen. Yeah. Let me just allow Google Chrome to get access to it because apparently this tab doesn't have access. And then we can get started.
All right.
Let me try it again now.
Lucas is going to be talking about testing, getting started with testing in JavaScript.
Apparently, I need to restart my Chrome. I'm sorry about that. I'll be right back if that's okay.
All right. Yeah.
Let me reconnect.
Yeah. Okay. In the meantime, I guess I can tell some jokes. I don't know. Better no. There we go. We have Lucas again. Hey, Lucas.
First time I'm sharing on ScreenYard, so my computer gets a bit annoyed. Okay, there we go. Okay, and everyone see it, right? There we go.
Now they can see it. Yes. I'll just get out of the picture. All yours.
Okay, perfect. Yeah, thanks Fernando for the invite. Again, it's a pleasure to be with you on the podcast as well. And yeah, today I'm going to be talking a bit about testing JavaScript applications, which is the subject of the last book I published with Many. And yeah, so basically I'm going to give you a quick overview of testing because, well, if something doesn't work, we all know that it doesn't matter how fast it doesn't work. So today I'll try to make this reasonably quick. I think this will be a good, thorough introduction, despite being so quick. So we're going to talk about determinism first. Then we're going to talk about the definition of good assertions, what good assertions are. We're going to talk a bit about snapshots and how to use them right. And then we're going to talk a bit about testing strategy, so whether you should test something top-down or bottom-up. And finally, we're going to discuss whether code coverage can be considered a good metric, as I discussed with Fernando last time, and it seemed like many people got interested in that. So starting with deterministic tests, I'd like to first give you the definition of a deterministic test, which is a test that, given the same input, always produces the same output. So if you give a certain function 1, it will always return true. There's no random behavior, there's no external dependencies. It only depends on inputs, and it always gives the same output. So that's essential for you to be able to write tests that are valuable. And tests that are valuable are defined as tests which fail, because tests which always pass don't tell you anything about the code. So if you have any assertions like this one, it will not be as obvious as expecting true to be true. But if you do have assertions which always pass, they do not provide you value. So if you imagine a test like this, for example, when you add items to the cart and remove items from the cart, if you just keep repeating the step that failed until it eventually passes, well, then you end up having kind of a test that always passes anyway. So the important thing about having a test that fails is that when something goes wrong, you will get the feedback on what went wrong. So if you do not make things go wrong, you cannot catch bugs, because tests, they don't serve to prove your code has no bugs. They serve to prove that you have a particular bug. And we're going to talk a bit more about coverage and tests in the last section. But just first to cover sources of indeterminism, so that you can avoid tests that are sometimes flaky. Because if tests are flaky, then it means that you have tests that can pass when your code is actually wrong. So there are 4 main sources of indeterminism that I'm going to cover in this introduction. First one is scheduling. So whenever you depend on time or timers or intervals or whatever that's related to time, that's number one. Number 2 is shared resources. So when you have like a centralized database or a centralized piece of state, which gets modified by multiple components. Third item is external dependency. So whenever you're dealing with HTTP requests to, for example, a third-party API or anything like that. And finally, synchronicity, when you have I/O that you cannot predict when it will be done. So to cover a bit all those sources of indeterminism and how to deal with them, I'd like to start with scheduling. So in this case here, we have a task which takes 10 minutes to run, because we have a function that we're testing that, well, takes 5 minutes and we have to wait for it twice. So this task is very, very slow. And it might be the case as well that we may wait for a promise, and, well, it might not yet have run by the time we do our assertion. So that's another thing that can happen when you're doing scheduling. So one of the things that you can do to avoid having to do with time and to wait for a long time for things to happen, or to even have that uncertainty of whether something will have occurred by the time you do your assertion, one of the things you can do with Jest is to use fake timers, which basically replaces the source of indeterminism, which is the clock, with a deterministic clock. So by using use fake timers, Jest will give you access to a bunch of APIs which will allow you to move the clock forward and trigger whatever intervals or whatever schedules that you have done. So in this case, we're using fake timers to avoid having to wait for 5 minutes. Instead, we just advance the timer by 5 minutes. So we fast forward 5 minutes, we do a check, we fast forward another 5 minutes, we do a check. And in that way, we know that 1, the things have run. So the things that were scheduled have run. And 2, we don't have to wait for things to happen. So that's how you solve the problem of scheduling. Now, one important detail to notice is that Jest, they used to have an implementation of fake timers that didn't mock certain functions like they don't now. So if you're using timestamps, you would probably find some problems there. But more recently, they moved to a different implementation of fake timers by default, which will mock every function you need. So if you're using this as a piece of code, this use fake timers, you might want to check which version of Jest you're in to make sure that the implementation covers all the functions you need. But that's how you deal with scheduling. Then the next topic is shared resources. So shared resources are another very common source of indeterminism when you have, for example, 2 threads that touch the same file and they use it as a piece of state. Especially given that Jest runs its tests in multiple threads, you can have race conditions and weird situations in which your tests will fail, although there might not be anything wrong. So in this case that I have here, for example, we have 1 test to increment a value and 1 test to decrement a value which touch the same file. And that's definitely going to be a problem depending on the order in which Jest picks these up to run. So one of the things that we can do to solve this problem of basically having centralized state which is manipulated in different order is to use the worker ID to get different instances of the same resource. So this piece of code, for example, will guarantee that each worker will get a different text file to modify. So if you use this, what is happening is when your tests are running, they're using get instance to basically write to different files, write and read from different files. And in that way, you can basically have tests which still run in parallel. So you still get the benefits of having tests that are quick. And you can have your tests being deterministic instead of making everything run serially and making things slow. Then third source of indeterminism is external dependency. So here in this example, we have a client which basically uses an app which talks to a third-party API. And we need to test the interaction of our app and the third-party API. So we need to know, what if the response changes? What if the API is down? How do I simulate my app's behavior when the API fails? So in this example, we do have a test which hits URL. So in this case, I'm using example.com, but it could be any API, and expects the body to have a certain content. So here, what I've done to avoid actually touching example.com is to use knock, which allows me to just say, hey, when this URL is hit, when you send this request, please don't actually send it, just give me this response. So that allows you to test things in a much more deterministic way. Yeah, and then the fourth topic is synchronicity. So this is kind of related to time in a way. So when you have asynchronous resources or synchronous workers doing things, you don't know when they're done. So you need to know, okay, when I send a request to my app, how long does it take for the message to be processed and my worker to pick it up and save it on the database? So in these cases, there are two ways to deal with this. The one I prefer is to use worker.emit. So emit an event with your worker in any possible way. So sometimes this will not be JavaScript code. Sometimes this might be another worker, but you can still have a queue to talk to basically the worker and say, okay, please tell me when you're done, and look at the messages that the worker sends back. So in that way, you can make your test deterministic. And another way of doing it is to use polling. So instead of just waiting for a very long time and doing an assertion once and failing, you can just keep polling in a certain interval and have a timeout. Now, I do prefer the previous method because it's quicker, but polling is also perfectly fine and may help you with not having to set up a lot of infrastructure just for a simple test. So now, second topic of today is good assertions. So one easy example of what a bad... So I like to explain good assertions actually by explaining what a bad assertion is. And one of the best examples of a bad assertion is this. So in this case, you have an assertion which expects a certain value to be 1 or to be 2. And this is a feature that many people have asked when I was working in open source libraries like Chai.js. And we always refuse to implement this particular feature because it incentivizes bad practices, in our opinion, because it kind of says, hey, this test is not deterministic. This result, it can be two things. If I give it a particular input, it may have two possible outputs. So here, if we allowed this into the library, we would be incentivizing tests to be non-deterministic. Now, this is what I call a loose assertion because it allows more than one value. And the way you define a loose assertion is by thinking, okay, among the universe of possible results, how many results am I accepting? Is it only one, or am I accepting multiple results? Like in this case, where you expect the type of the result to be number. In this case, well, you can have a bazillion possible results which will pass this test. So any number in JavaScript will pass this test, including not a number, whose type is a number. So yeah, that would make your test pass if you're just checking whether type of name is number. Now, another example is expecting the result to be greater than a certain number. That is also a loose assertion. So if you're expecting any number greater than 1, well, you have just half the universe of possibilities than an actual check for a number type. So that's also bad. Now, the more you restrict it, the better your assertion is. And in this case, the best possible scenario is to be able to have a result which can only be one single result. So in this case, we're expecting results to be true, and it will always be true no matter what happens in all situations. And now, one of the things that I see many people doing is using not when they write assertions, but I don't like not because it's just another way of writing a loose assertion. Because when you use not here, I am expecting result not to be true, and that means that I am expecting basically the same universe of possible results than if I was checking for the number type, but I'm just excluding true from it. And that's why I recommend people to avoid negating assertions, so avoid using not, because it makes the assertion loose, basically. So when necessary, when you need to have some flexibility, I'd use matchers, like in this case, when you expect any date in a particular field. So in this case, it would be probably better to actually mock date not now, or the function which generates this particular date. But if you do have to use loose assertions, I would use matchers to match particular properties in an object or things like that, for example. And I'd be very careful when using them. Now, third topic is snapshots, which is also very controversial. So I do like snapshots, and I do think, yes, you should use snapshots, but I do think you should be careful. So I would use snapshots mostly for testing complex output. So when I have a longer text file or a huge HTML page or CLI output or anything which would basically mean I'd be copying code from my terminal when it goes wrong and pasting it into my test file, and I would be just looking at whether what I pasted makes sense. So if you're gonna copy and paste results anyway because they're too long and you're just visually gonna go through it, while using a snapshot is basically the same thing, is just much easier. And well, I'd also make sure to use serializers if I'm using snapshots, because they would just make code easier to review. It would be quicker for me to find mistakes, and they would remove any clutter from my snapshot, and would be much better for people that are doing reviews. So one good use case for snapshots that comes to mind that I always talk about is how Jest uses snapshots test itself. So what Jest does is, when you see these pieces of output in your screen, when you see a test summary or anything like that, the way Jest asserts that those are correct is by actually running Jest, getting the output, and then comparing it to a snapshot. Because the output is too long, no one is going to actually keep typing every single character exactly as it is on the terminal output, including all the spaces, all the tabs, and all that. It's just not going to happen. So that's why they use snapshots. Now, the way snapshots work is basically when you use an assertion which expects something to match a particular snapshot, there's a serializer which creates the snapshot file, and then once that snapshot file is created, it's just reused for further comparisons. And yeah, so that snapshot, that was number 3. Then for number 4, we have a topic that's a bit more complex, is more strategic when it comes to testing in a way. And it's whether you should test things top down or bottom up. And what I mean by that is whether you should start by the bottom of the pyramid or the top. And for those that are not familiar with the testing pyramid, basically at the bottom, you have unit tests, which test a single function. And they're more frequently run, and they're more isolated. So above those, you have integration tests, which may test 2 or more functions. And then they have some more integration because they test multiple pieces of your code. And they take a bit more time to run, and they run a little bit less frequently because of that. Then finally, at the top, you do have end-to-end tests, which are the more valuable and expensive kinds of tests, which are less frequent because they take a significant amount of time to run in most cases, and they're less isolated. So basically, they test your whole code from the point of view of user. Now, one important thing that I always like to highlight when I talk about the pyramid is that I don't see these as absolute categories. So I don't think a test fits in only one of these categories. It might fit anywhere in the spectrum. So you might have a test that tests multiple functions, So it is kind of an integration test, but it doesn't test, your software from the point of view of the user. It doesn't maybe open a browser or anything like that. So, it might be anywhere in between an end-to-end test and integration test. And the reason I also don't like the integration test naming is because, well, if you're testing an API by making requests to it, is that an end-to-end test? Because, well, the API is a full package anyway. But in a sense, well, it might not be how users use it. So that's why I don't like the terminology a lot. I just like to think about that as a spectrum of going from more isolated tests to less isolated tests and more frequent tests to less frequent tests. That's how I think about it. So to talk about what issue test takes top down, so write unit tests first or intent tests first, there are a few things you should consider because I don't think there's a silver bullet and a single answer to this. And well, one of the things that you should take into account is time. So how long would it take for you to cover all these pieces of code? Well, if you just test the topmost function, which calls all the others, well, then you get a lot of coverage with a single test, which is probably easier and quicker to write than testing every single function individually. And it also takes less time to maintain. So this is what a top-down approach would look like. You call the topmost functions, which call the smaller functions. So in this case, you just test the function on the top here. So generate inventory report, and that's how you fit it into time. But if you go bottom up, well, you first test the two functions that this function on top calls, and only then you test the one above. Now, there's a trade-off to make there because you do get more granular feedback if you start from the bottom. But if you start from the top, you get a lot of coverage straight away. Now, another thing you should consider is confidence. How confident are you in your tests? So this relates a lot to TDD. Some of you might be familiar with this image that I have on the screen as the TDD virtuous flow. That's how you do TDD. You basically write a failing test, you get a passing test, and you keep refactoring until you're satisfied with the results you got to. So if you're writing tests and you're deciding whether to take bigger or small steps, well, the thing you're going to use to decide that is how confident are you in the piece of code you're going to write? How complex is it? So when you're not very confident, when you're writing a very complex function, which may probably get too long, I'd probably recommend, just run through the flow multiple times. Just write a failing test, a very small one, get to a passing test, refactor, and then keep going and going and going, adding slowly all the functionality you need. Because having that fast feedback allows you to not deviate too much from what you intended to do because you just waited too long to see whether something worked. Now, the more confident you get, the smaller your cycles become. So the less iterations you do. And if you're very confident in a function, well, you might just write a failing test, a full-blown failing test, and get to a passing test straight away. And that's a big misconception that people have about TDD. They think you should always do this straight away. But no, that's not what TDD is about. TDD is about taking these small steps. So if you're not confident, if you're just starting out, maybe you need to warm up or whatever it is, you might just want to start your test by importing a file and calling a function which does nothing. That will avoid, for example, you having to go through a file hierarchy to see if you typed a file path correctly. And well, if you're very confident, if you're already very sure of what you're going to do, well, then you can do this. TDD is not prescriptive about how big your test should be. It all depends on how confident you feel. Then next thing is coverage. So here I'm not talking about just coverage metrics. What I'm talking about coverage is, can I test all edge cases of this function? That's what this here was saying. So in this case, if I call generate all reports and it calls this function, which calls this function, will I be able to simulate all the possible error scenarios for this? Maybe the way this function on top interacts with the function on the bottom doesn't allow me to have this function throwing a particular error. Maybe, it's not possible to pass a particular string, or maybe there is a lot of filtering up here, which makes this function always pass. But if this function is critical, I do need to cover it directly by test, because if someone's going to reuse it, I want to know when it fails. So you do have to consider how granular your feedback will be when making that decision. So if you're going to cover a small part of your code, well, it means you have more control over it and you have smaller error surfaces. So in this case, if we test the function on the top, which calls all the ones on the bottom, and the tests fail, basically my error surface is all the functions which are called by this one. Now, if I test one function here on the bottom, my error surface gets smaller, because the error surface for a test failure here is just this function and the two functions on the bottom. Now, what to do in this case? Well, as I mentioned, you can cover functions which are called by multiple other functions with their own tests. So if you do have to reuse something a lot, it might be worth just getting, very deep into, does this function work for all possible inputs that I can think of that are weird, or any weird scenarios? And that will allow you to make a trade-off between how long your test will take to write, because you might want to test something from bottom up in this case if it's that important, and it will allow you to get granular feedback, and it will allow you to be confident that that particular function, which gets reused a lot, which is critical, works. And yeah, and then what about mocking? So what impact does mocking have when I'm deciding, whether to take a top-down or bottom-up approach? So in this example, if you're mocking everything below your topmost function, it allows you to have a smaller error surface, even though you're testing things from top down. So if you have mocked every function that generates or reports calls, and you're sure that these mocks just return the right thing, well, then your error surface becomes just the topmost function. Then that's a choice you have to make based on whether you want granular feedback or integration, because the more you mock things, the less tests resemble real use cases. Imagine, for example, if there was a failure here and you didn't have tests for this function. Now, if you're mocking it, you're not covering it. You're not testing things in a way that your users would. So there is some trade-off that you need to consider there between, how reliable your tests are and how much mocking you do, to get some time when you're testing things. Now, when to mock things? Well, when you need to simulate failures, like for example, in the previous example where I had an API call, I could easily simulate the API returning a 500 or anything of that kind, to see how my app behaves and test that its error behavior is okay. Another situation is to obtain granularity. So the smaller your possible error surface, the more granular input you get. So here, in this case, you have a very small error surface because you have mocked everything down below. So you get very, very granular feedback. And then finally, to also replace sources of indeterminism, which is very similar to simulating failures in components you can control. But if you're using, for example, an RNG, that could also be a good way to make tests deterministic. And in a way, using fake timers is kind of mocking, because you're basically just replacing the clock with your own functions. Now, to finalize this, the most controversial topic is code coverage a good metric? So I was talking to about this with Fernando last time in the podcast we've done, and one thing that I've said there was that code coverage doesn't measure quality. Just because you have 100% coverage, which I don't think exists, well, it doesn't mean your tests cover all possible scenarios. Your test catches all errors. There's no metric which will prove that your code has no errors. So in this example, where you have this sum or divide function, you can write, lots of tests. You can get into both branches and you can get 100% coverage. But if you first don't write the necessary assertions, well, you won't catch any errors, because code coverage only indicates that your code can run. And it may not even indicate that's nice, because, well, what if A is odd here? So you get to the bottom branch, and b is 0, so we're dividing by 0. Well, in that case, we don't have any assertions, and even if we get 100% coverage, well, we have a bug in our code. So yeah, code coverage doesn't guarantee quality. And there's one interesting quote by James O'Colpin, which I always like to use to illustrate what I mean by this, which is this one in his article, Why Most Unit Testing is Waste. So there he says that he defines 100% coverage as having examined all possible combinations of all possible paths through all methods of a class, having reproduced every possible configuration of data bits accessible to those methods, and every machine language instruction along the paths of execution. Anything else is a heuristic about which absolutely no formal claim of correctness can be made. So yeah, so there's just no way you're gonna test every single component of your machine, everything in your software stack, and even if you do, there's no guarantee that you're gonna pass it the necessary inputs and necessary combinations of tests among all those components to make something fail. So, well, I would indeed recommend people to have a look at code coverage because, well, it helps them find unused branches in their code. But one important thing is not to rely on it too much and say, "Oh, I have 100% covered, therefore things are fine." No, you still have to pay a lot of attention to what inputs you're testing. What are your types like, and all that. So yeah, so I think that's pretty much it. I hope it was a good introduction, and yeah, I hope we were able to catch some of the most common mistakes that people do in writing some tests.
All right. Fantastic. Thank you, Lucas. That was very detailed and interesting. We don't have any questions right now, but this is gonna be available anyway on the VOD on YouTube and Twitch anyway. So I'm sure we're gonna have some conversations there. So let me get everyone back in. As a reminder, I mean, Lucas mentioned it, but if you want to hear more from Lucas on this topic, we have an episode 9, I think, of the 20-minute JavaScript podcast, when we also discuss some different topics and some also the same about testing and testing JavaScript and unit testing. So that's a very interesting one to check out as well. All right, so let me just quickly finish the call. I mean, as a reminder, we're doing this every month, so make sure you tune in for next month a call, and also to a reminder that this is all saved on YouTube and Twitch. So if you want to check out last month or any previous call, go there to our YouTube channel, just or hit us up on any of our channels here shown here, either the Slack or Twitter, and we'll be happy to share the links and answer any questions. And finally, before we leave, as a reminder, we're also hiring. We're looking for Go developers, JavaScript developers, and product managers. So if you are interested in one of these roles, or if you know anyone who might be interested, reach out to us and send us the connection, and we'll take it from there. And that's it. Thank you, all our speakers. This was a very interesting one, very filled with details. So that's it. Again, thank you, and see you next month.
Thank
Bye.
you.
See you.
Thank you, Lucas.